Have you ever stopped to think about what the world is really made of? I mean, everything. You, me, this screen, the stars. It turns out it's all built from a surprisingly small number of basic ingredients. Today, we're going to find out what those cosmic building blocks are. Let's get into it. So here's our game plan. First, we'll look at the universe's building blocks. Then, we'll crack the code that scientists use to talk about them. We'll get to know the first 20 of these elements, unveil the ultimate scientific cheat sheet, and finally, I'll show you exactly how to read it. All right, let's kick things off with that one massive, super fundamental question. If you could break everything down to its smallest possible part, what would you find? Now, really, just think about it for a sec. The air you're breathing right now, the ground under your feet, what's the one thing that connects them all at their absolute core? And the answer is these little tiny particles called atoms. You can think of them as the universe's official Lego bricks. Absolutely everything is just a different combination of these same basic bricks. So let's get that definition locked in. An atom is the smallest possible piece of an element. You just can't break it down any more than that. It is the fundamental particle that makes up, well, all the stuff in the universe. And that brings us right to our next big idea. See, when you get a whole bunch of the same kind of atom all together, that's what we call an element. So a chunk of pure gold, that's an element, because it's made of only gold atoms. Simple as that. Okay, so scientists started discovering all these different elements, which was awesome. But it also created a pretty big problem. How were they all supposed to talk about them without getting totally confused? I mean, just imagine a scientist in Germany discovering something and a scientist in France discovering something else, but they call them by different names. It would be total chaos. They needed a single universal system that everyone could agree on. And the system they came up with is actually pretty brilliant. It's just 4 simple rules. Rule 1, you take the first letter of the name. So oxygen becomes O. Easy enough. But wait, what if another element starts with O? That's rule 2. If the first letter's taken, you add a second letter from the name. That's why helium is He, not just H. Rule 3 is for the weird ones. Their symbols come from old Latin names. It's why sodium is Na. And the last rule, the golden rule, the first letter is always a capital and the second is always lowercase. And boom, you've got a universal language for chemistry. Okay, so now that we know the lingo, let's meet some of the most important characters in our story. We're not going to tackle all 118 today, don't worry. We're just going to start with the first 20, which, by the way, includes a ton of the stuff that we're made of. And here they are. As you look through the list, you can see those rules we just talked about playing out. Carbon got to be just C, so calcium had to be Ca. And there's our friend sodium, Na, and right below it, potassium is K. Those are a couple of those Latin-named elements. It's a really elegant little system, right? Now, having a list is great and all, but scientists quickly figured out that just listing the elements wasn't going to cut it. They realized there was a much smarter, much more powerful way to organize all of them. A way that would show hidden patterns and reveal how all these different building blocks were related to each other. And this is it, the periodic table. I know, it can look a little intimidating, but trust me, it's not just a boring chart from science class. It's basically the ultimate cheat sheet for the entire universe. It's a map to how everything works. So this one table neatly organizes all 118 elements that we know of. And here's the wild part. 94 of those are found in nature, but the other 24, we actually made those in a lab. We are literally adding new bricks to the set. So we have this incredible map, right? Now let's learn how to actually use it. It's time to unlock its secrets. Okay, so it's all organized by rows and columns. The rows that go across are called periods, and as you move from left to right along a period, the atoms just get heavier and heavier. The columns that go up and down are called groups, and here's where the magic is. Elements in the same group are like a family. They have super similar properties. For instance, everything in that far right column, like helium and neon, they're all called noble gases, and they are famously unreactive. They're kind of like the too cool for school kids of the periodic table. All right, you ready to put this all together? Let's do a quick little quiz. First, what are the full names for the symbols Mg, Be, Li, and N? Next, what are the symbols for aluminum, boron, fluorine, and potassium? And for the last one, think about how the table's laid out. Which of the first 20 elements has the heaviest atoms? Go ahead and pause here if you want to give it a shot. Okay, you ready for the answers? Mg is magnesium, Be is beryllium, Li is lithium, and N is nitrogen. The symbols are Al for aluminum, B for boron, F for fluorine, and K for potassium. And the heaviest of the first 20? Well, since the mass goes up as you go across and down the table, it's the last one on our list, calcium, Ca. So how'd you do? And really, this is the main thing to remember. The periodic table isn't just a catalog, it's a predictive map. A scientist can look at where an element is on the table, see its neighbors, and make a really good guess about how it's going to behave. That's its real power. So we've gone from a single tiny atom all the way to this incredible map of 118 elements. But it kind of leaves us with one last really big question. If we've already created 24 new elements ourselves, is this list even finished? Or are there more cosmic building blocks still out there just waiting for us to find them?